So we'll wait for another 5 to 10 minutes, and then like another 5 minutes. Then we'll start the session because only 5 people are here. So we'll wait for more to join. So am I audible?
Yes, you are audible, sir.
Okay, thank you. Thank you for the confirmation. So how many of you have joined the live session by the instructor that was held this week? Anyone of you have joined that session? So we are 8 people here. Uh, how is your experience? Like how this course is going on? Can somebody, anyone want to share something about the course and any difficulty they are facing during this course? Like till now, 4 weeks are completed. So we are in the week 4 of the this course. So is there any issue or is there any problem or difficulty that you are facing related to this course on NPTEL? If anyone want to share something.
I think course is going on the in a good arena, and the pace is good, and we learn more things. But we more focus on the design of mechatronic systems.
Yes.
So I think the beside we have discussed, sir have discussed about the production systems, different types of in welding, it's a forming, it's a casting, but we need to more focus on the mechatronics systems, design of mechatronic system.
Yes, yes.
In
So
the coming time, we I think so the mechanical is shifting in that direction. So
yes.
our aim is only to more focus on the mechatronic systems design. Thank
Hmm.
you. And everything
Okay.
is good. Everything is good.
Okay, okay, Rakesh. So thank you for your like suggestion or feedback, I can say. So for your information, like this initially, the manufacturing systems that you have studied or the processes that you have studied, and all these sensors and all the basic things that is covered in the course is just a building block for this course, uh, like automation in manufacturing. So what we are going to do? So we have studied about the manufacturing processes. We are understanding the use of sensors and applications of sensors, and now in further upcoming sessions we are going to design we are going to study, or we are going to see how we can automate that manufacturing processes. right? So in the current era only, this manufacturing, the conventional manufacturing thing is going to be automated on the production line also in the industrial scenario. So till now we have in the course we are covering the basic things, so that everyone, like, because the population in the enrolled in the course is like from different background, maybe electronics people are there, electrical people are there, maybe mechanical people are there. So for mechanical, they are not aware of much aware of this sensor and everything, and for electrical or electronics people, they are not much aware about the processes. So to bring everyone on the same platform, initially these kind of topics are covered in this course. Later on we are more focused, yeah, as you said, we have to focus on automation. So this course is only designed for that thing. So automation in the manufacturing, as it says, so it will surely and certainly aim towards the designing and development of or implementation of automation in manufacturing, or in the manufacturing this scenario, right?
Thank
So,
you.
okay, now we'll start today's session. So, hello everyone. Good afternoon. I welcome you all again. We are in the fourth live session of this course, Automation in Manufacturing, which is offered by NPTEL under the course code of NOC 22ME133. So, I am Swarit Anand Singh. I am pursuing PhD in the Department of Mechanical Engineering. I am a Prime Minister Research Fellow. So through Prime Minister Research Fellowship and this NPTEL TA scheme, I got this opportunity to get interacted with you and discuss the problems and queries that you have in this session. So I hope you have enjoyed the last three sessions that we have took. Every Saturday we are meeting on the same time in the same on the same platform with the Google link. Uh, in this week, Professor S.N. Joshi, the course instructor, was also there to interact with you. Hope you have availed this that opportunity, and that session I have also joined in that session. So it was a very quite interesting and interactive session. So. Okay, in this session again, those who are new, I just want to convey this information that we are here in this session. So this session I have planned in three parts. Okay, so first part I used to discuss the old assignment problems. So the problem that I will that will be in like multiple choice type questions. I'll give on the screen and I will ask you ask the answers from your side. So your participation is more much more important, and it is required for conducting this session. And then in second part, I will take the questions that are asked on the course forum, the discussion forum. So I will discuss those questions, and in the third section of this session, I will interact with you one by one, and if you have any query, we'll discuss, and I will try to solve all your queries related to this course. Okay, so moving towards the first section of this session. So here is the first question on your screen. There's a statement written: all sensors are transducers, but all transducers may not be sensors. So this statement is true or false? What is your answer?
I think it's true. All sensors
True.
are transducer, but all, yeah. Sir, I told you.
Okay, Rakesh is saying true. T. Sankar Lal is saying true. Sumitra thought true, true. Okay. Yeah, so this statement is obviously a true statement. So can somebody tell me what is the basic difference between sensor and transducer?
Uh, Sensors are only sense only detect this, and transducer is the convert the energy form. I think this is the
Yes,
basic
yes,
difference between them.
yes, yes. So these are the basic, like on the screen you can see a table. So like as per definition says, so sensor is the some is a device that sense the change and gives the reading in same format of the signal that is received, right? So it required, if you want to convert that signal to some other form of signal, you required some external device to convert that. But transducer, on the other hand, it sense the things and then transform the signal into some other form. Like, so it may be like from electrical signal to the non-electrical functionality, or from non-electrical signal to the electrical signal, vice versa. So example of sensors are there like pressure switches, thermistor, thermometer, motion sensors are there. Like for transducer, there we have microphones we have seen. So microphone is a transducer. And for application purpose, like this as mentioned on the screen, like pressure level in oxygen tank can be measured by sensor, can be monitored by sensor. But for transducer, we use transducer for engine control, or for controlling of bridge lifting or positioning of this kind of application. We require transducer. So this is very so this statement is very clear, and everyone, I think, you don't have any confusion about this statement. So next question is on the screen now. So question is like orifice meter works on the principle of, on what principle this orifice meter works?
It's a
So
Bernoulli's.
okay, so Rakesh said it's Bernoulli's. Again, Karthik, Sumit, Bernoulli. Okay, option A they are saying. Abhishek, A option. Okay. Yes. So orifice meter, we have studied this orifice meter from like in 12th class physics maybe. So since then we know this orifice meter works on the principle of Bernoulli's theorem. So what is Bernoulli's theorem? Question is now, what is Bernoulli's theorem? Or what do you know about this Bernoulli's? Anyone? So I hope you have gone through this kind of equation while studying class 12 physics, or maybe those who are from mechanical background or who have done the course on fluid mechanics. So they must have knowing this equation. So this equation says the pressure head, the velocity head, and the potential head, you can say the kinetic head and potential head, the summation of all these heads are constant in a fluid flow. So there is a orifice meter you can see on the screen. Okay, so this orifice meter, like there is a there's a orifice plate, so which create vena contra zone. Like, so fluid is flowing from this side, and once it is going to enter from this orifice kind of structure, so it creates a low pressure zone this side, right? Because velocity is high here, so it creates a low pressure zone this side. So with the help of this, we can certainly measure the pressure or something like that with the help of this equation. Right? So this is a Bernoulli's theorem. Any confusion in this? Okay, so on this chat box, we can see some answers. So Abhishek Kumar says P1 V1 equal to P2 V2. Okay, and then T Sankarlal said total energy of fluid at given point between 2 point. Yeah, so this is the correct statement that Bernoulli says. This total energy of the fluid at given point or between 2 point is constant. Okay. So now moving towards next question. The third question is on the screen now. It says in capacitive element, the capacitance of a system increases with. The options are increase in both area or overlap and distance of separation. Second option is decrease in both area of overlap and distance of separation. Third option says increase in area of overlap and decrease in distance of separation, and then D is the vice versa of C statement. So B,
C.
C,
I think
C,
C. Increase
C.
in the area of overlap and decrease in the distance of separation. I think.
Okay. So yes, the answer is C only, because the what is the formula? This formula is formula of capacitance says that C is equal to epsilon A by D, where A is the area and D is the distance between the plates. So here you can see these are the two plates, and this distance is D, and this is the area. Area is of area of the plate. Okay, so area of the plate is A. So here we can see that like C is directly proportional to area or area of the plate, and then this capacitance is inversely proportional to distance. So if we increase the area of overlap, so the capacitance of system is will increase, and if we if we increase D, means the distance between the plate, it will decrease. So if we want to increase the capacitance, so we have to decrease D. So option C is the correct answer for this. Now moving toward fourth question. Fourth question is on the screen now. Fourth question says the strain gauge based sensors, the strain in the wire increases with increase in. So if you have studied this about the strain gauge based sensor, so you have seen that strain in the wire cause some change in the resistance, right? So what like what is the correct option for this statement? So tension along the length, compression along the length, tension along the lateral direction, or compression along the lateral direction. In strain gauge based sensor, any answer?
Tension along the length, I think. F is equal to S.
Tension along the length. Okay. Anyone else?
Sigma is equal to E times E, and E is equal to delta L over L times modulus of elasticity, and sigma is equal to F upon A. So F of
Anyone else want to answer this question?
delta L upon A into E. So it's on based on the tension along the length. Yes. A. Confirm.
Okay. So Rakesh says A. After his calculation, he has just got the answer A. Anyone else? Some people are saying C. Okay. Okay. So the answer is tension along the length only. So you must have gone through this. You have seen this photo maybe. So in the what you can say tension along the length, if we stretch the strain gauge based sensor, so these wires are in tension on the along the length. So the resistance of that wire changes, and this is a principle for this strain gauge based sensor. So it is tension along the length only. Yeah. So Sumit again saying tension along the length. Yes, it is the correct answer. Now moving towards the fifth question. So it is just a full form of RVDT sensor. So what is RVDT sensor? What is the full form of this RVDT? D. D is the rotary variable differential transformer. Okay. So Chandar Kamra is saying A. A is the rotary variable differential transducer. No, it is not A. Answer is D only. So it is rotary variable differential transformer. So basically, RVDT looks like this. So there is a primary circuit, and then due to the inductance property here, it induce EMF here, and then it transfer to the secondary coils. So this is the rotary variable differential transformer only. Next question is on the screen now. Question is like to monitor the orientation of textile fabric during the garment manufacturing. Among the following, which sensor would be suitable? So, have you seen any textile fabric plant? Anyone? Anyone have visited such kind of plant? Abhishek Kumar, yes. So Abhishek, unmute yourself and can you? I have FDY. So Abhishek Kumar, you can unmute yourself and just say something about your experience and share your experience about visiting that textile fabric plant. What you have seen there. Just you can unmute yourself and just I'm unable to communicate. Okay. So what you have seen, I have FDY full drawn yarn. Okay. So no issue. Anyone else who has visited some fabric or textile manufacturing plant or something like that or related to that? No. Okay. So no problem. Like in textile fabric, this manufacturing, I have visited one plant recently. So that is a Kanpur Plastic Pack Limited in Kanpur. So there, what they do, they used to make the what you can say this packaging packets. Okay. So For that, their rolls of the fabrics are made. So those rolls, when those rolls are cut it into the small pieces for stitching operation. So before that, there is a cutter. So once the roll is going to, like, it is a automated machine only, that that full line, that production line is automated. So the roll is fit into that machine, and the cutter is there, which automatically pulls the that text, that fabric, and then cut for like a specific length of the fabric, it cut every time. So since it is roller there, roller, which is this fabric is rolled on that roller. Okay, so it may goes like, it can translate. Okay, so it, due to some vibration, so its position may change in the, like, if suppose I'm stretching it, so it can have some vibration or some, what you can say, flying motion in between. So if it goes like, if it comes under the cutter in some tilted position, so it will cut like, it will not cut the straight, what you can say, that fabric. Okay, so that will create problem in later stage while stitching. So that's why, for monitoring that, okay, so they have installed this sensor at both side of the, that from where the this fabric is passing. So they used to place two sensors at each side. So if it crosses the line, so if it crosses the line, it goes outside, so sensor sense it, and then it automatically also correct it. So there is some attachment is there, so that it can just push the roll at in opposite direction. Okay, so by this way, this
This is a process of a winder.
yes, yes. So I'm just
Full
talking about.
in Yes, sir. In my company. I'm right now. I'm in the office,
Okay,
so
okay.
that's because I am unable to communicate. But in my company, there is also have a fully drawn yarn,
Mm-hmm.
a plant FDY name,
Mm-hmm.
and that plant is fully automated,
Okay, okay.
totally automated,
Hmm.
and their production capacity is around 80 kgs and per 60 minutes.
Okay.
Yes, sir.
That's nice. So you must have like the different amount of sensor, like different sensors you have installed
Yes, sir.
in your plant, right now?
Yes, sir. Yes, sir.
Okay. So
And
yeah.
yes,
So
sir.
be, being a like a since when these sensors has been installed in your factory? Like,
Sir, there are totally a plant which is uh, FDY प्लांट जिसमें सॉरी मैं हिंदी में बात करूं
हाँ हाँ, क्यों क्यों नहीं?
हाँ तो सर इसमें प्लास्टिक से हम यार्न बनाते हैं
हम्म.
तो देन सर इसमें पूरे प्रोसेस में सर ट्रांसड्यूसर भी लगते हैं सारे सेंसर्स लगते हैं तो
Yes.
आपको कौन से सेंसर्स के बारे में जानना है
हम्म.
तो
Okay.
उस चीज के बेसिस से है
Okay.
और
Yes.
जो
So
वाइंडर है और वो जो वाइंडर है सर वो वाइंडर आपका मैं क्या आप कंटिन्यू करिए सर
okay. Okay, so Abhishek, thank you for sharing your experience. So he is like in the factory. So that is a yarn drawing factory, something like that. So in his factory, he has like, he's saying that he has installed several kind of sensors and transducer for different purpose. So I have shared one of my experience which I have seen. So yeah, so for coming to this question, so the question is like, to monitor the orientation of textile fabric during the garment manufacturing. So which kind of sensor is installed? So someone said inductive proximity sensor. So inductive proximity sensor, like if you have studied the course, so it says like it is used for uh, metallic component, right? So for fabric, it will not be suitable to install this inductive proximity sensor there. It can be suitable for something like, if something metallic component are there, like if it is in place of this fabric, if you have metal sheets, so you can obviously place inductive proximity sensor there. So for this textile fabric, the answer is pneumatic sensors, right? So with the change in the pressure, air pressure is there. So with the change in air, the change in air pressure will be observed once in between the gap. Some other like the fabric will come, so the pressure will change, and due to this change, it is sensed by this pneumatic sensor. Okay, and then the corrective answer action is performed by the transducer, right? So is there any confusion? Anyone want to say anything? Okay, so moving to the next question. The question is on the screen now, seventh question. So in general, to sense the objects, the fingertips of robot arms are equipped with. So T Shankar Lal says
Tactile,
C. Okay.
tactile sensors.
Tactile sensor. Abhishek is also
रीड
saying
स्विच.
C. Read switch.
यस सर. राइट
Okay.
नाउ सर मेरे सामने ये भी एक रोबोटिक आर्म है
Uh-huh.
और उसमें उसके जो टिकर है सर उसमें रीड स्विच लगा हुआ है.
Okay. So what it is doing? Like for what purpose
सर
this read switch?
सर ये सिर्फ सेंस करता है जब वो हमारा कंपोनेंट इंजेक्शन मोल्डिंग से
Mhm.
बाहर की तरफ आता है.
Okay. Okay. So it sense only.
इट सेंस ओनली. इट्स एन इनपुट सेंसर.
Hmm.
और सिर्फ ये सेंस करता है कि जब पिकर को ड्रॉप करने, पिक एंड प्लेस करने के लिए.
Okay. So here what like that process is of sensing only, right? So
Yes.
here in this question, what it is asking, like it is asking just like if you're using your mobile screen, like so you touch, so some command is given to the that processor of your mobile, right? So for touch screen kind of thing, that kind of function, so which type of sensor it uses? So read switch is for sensing the incoming and outgoing, like it is for that kind of thing. But for sensing or for replicating the what you can say, the sense of like fingertips. So this read switch is not a suitable option for that, right? So suitable option is the tactile sensor, right? So tactile sensor is there is some piezo electric material, okay, that we call PVDF. Okay, so there's if some pressure or force is applied over that, so it will generate some amount of like what you can say, voltage. Okay, and then that is converted and that is converted further for like for further use of whatever the application is there. Okay, so for the this kind of application where we are involving like we want the feeling of this fingertips, so we use tactile sensor, right? So moving to the next question. Next question is on the screen now. The question says, in resistance temperature detectors, the resistance of sensor element, option is increases with increase in temperature, decrease with increase in temperature, remain constant with increase in temperature, or remain constant with decrease in temperature. So it is talking about relationship between temperature and resistance. So we are getting option A. Okay. Yes. So the answer is it increases with the increase in temperature. So you have this formula that resistance is directly proportional to the that temperature. Okay. So if we have reference resistance and then reference temperature, so we can measure the unknown resistance by inputting some uh, known amount of temperature there, right? Now, ninth question is on the screen now. The question says like, as per which effect, when two dissimilar metal holds together at their end, potential difference occurs at the junction.
Effect. Seebeck effect.
Seebeck effect. Yes. So yes. So all of you are saying Seebeck effect. Yes. So in Seebeck effect, what is happening? Like we make junction of two different material or what two different wire of two different material, and then if we if we provide heat at one of the junction, so there will be some potential difference occur. So moving to the last question of this session. So the question is the photodiode is basically which type of diode? PNP junction diode, NPN junction diode, or NP junction diode? D. Okay. PN junction diode. Okay. Yes, D. So yeah, so it is a PN junction diode actually, PN junction device. So this is a structure of like PN junction. So why it is called PN junction? Like the two different regions are joined together, and then there is a depletion layer uh, generated. So which is known as that PN junction, and then it is connected with some what you can say the if some EMF kind of thing is generated there, right? So this is a this junction is there in the photo diode. So in photodiode, uh, the light rays falls on this PN junction, and then due to that, the change in voltage is observed, right? So these are the questions from my side that I have prepared for you. Now we will discuss the questions that are posted on the discussion forum one by one. So the first question that I saw is like this is the question that you can say it belongs to some week one content. So in week one we have studied about a type of system. Okay, so that was work manual system, machine system, automatic systems, and this kind of thing we have studied in first week. So he asked it bit late, but we'll answer this question that he says, sir, nowadays carpenter are uses some electric equipment, then I can say that type of work is manual work system. Okay, so no, so definitely it is not a manual work system because you are using some electrical equipment there, right? So if you can the manual work system is where the manual force or the force of human being, like energy of human being, get consumed for performing some work or performing some task, right? So if some machine or some other equipment is performing the task, and you there is no effort from your side, you are just holding that device. Okay, you are not doing anything, you are not applying pressure or nothing. So that is not the manual work system. Okay, so that will become machine manual system kind of thing. So this question is answered by the TA there on the discussion forum. It is like these sort of equipment basically termed at worker machine system. Okay, as the shearing phenomena is using electrical energy as the source, but carpenter defines the feed motion physically only. Like, so carpenter is not applying his own energy to perform this the operation of like cutting or drilling, maybe whatever. So we have seen this machine. Okay, so with the first machine is this is called manual work machine system. So why it is manual work machine system? As I already discussed, those who have joined the first session, so we have discussed this. So because here what this is machine, okay, but the operation is manual. Why it is manual? Because there is a spindle. Okay, so the carpenter or the operator who's there, so he used to rotate this, like he apply his own energy. Okay, and due to this the rotation of this is converted to the rotation of the drill bit. Here suppose there is a tool, there will be tool and the workpiece is there. So this the rotation to this true tool or tool or this drill bit, you can say, comes from the energy that is applied to this spindle. Okay, this handle. So this handle is rotated by operator manually. So this comes under manual work system. Okay, although there is a machine, but it is a manual work system. Now you must have seen this kind of drilling machine or the drilling machine that you have at your home, or many of you have seen a normal carpenter use. This time they used to plug it with some electrical power and then used to press the button and perform the operation. So this is a extended version of that. This is the workshop drill machine. Okay, so this kind of drill machine you can see on in workshop. Okay, so here what is happening, we don't need to, or operator don't need to apply his energy to rotate this tool, this drill bit or this tool. Okay, so it is done by this motor. So this is electrical motor. So that is done by this. Okay, this electrical motor supplies the energy for rotating this tool, and that tool perform the cutting operation. So this kind of machine comes in the worker machine system, right? So worker has to just fix the workpiece there on the bed, and where he want the cutting operation or the drilling operation to be done, right? And then he have to change the tool and everything, like or up to what depth he want to drill, or up to like which with what feed rate he want to continue the cutting operation. So all these physical things, the manually is done by a human operator, and the cutting operation is done with the help of the electrical energy this motor is consuming. Okay, so with the help of this motor, the power up from this motor, this tool is rotating. So this comes under worker machine system, right? And finally, there is an automated system. Sorry, so there is an automated system. So this automated system, again, you will find this kind of automated system in some factory or on the in the workshop only. So this kind of automated system are like, we used to feed some code. Okay, CNC code will be there, and we mount the workpiece on the workbench, and according to the CNC code, it will perform the operation. You do not need to do anything else. Okay, you do not need to intervene the machine during its operation. So this comes under automated system. So is there any confusion now regarding this? Anyone of you? Manual work system, work machine system, or automated system? Will you able to easily identify these kind of systems once you see?
Yes, it can be easily identified.
Okay, thank you, Rakesh. So moving to the next question now. So it's not getting it. Just a second. Okay, there is some issue. So yeah, so second question is about the regarding FDM and 3D printing. So this FDM and 3D printing, again, it is not from this week course. It is in week 3, I think. So it says, like, question is like, in lecture 9 fabrication process, professor designated selective powder binding as a modern day 3D printing, but it seems like fused deposition modeling FDM work in the same principle to generate 3D prototype models. Okay, so selective, like the answer which is mentioned on the discussion forum was like, selective powder binding is generally known as 3D printing method. Fused deposition modeling is a material extrusion technique in which polymer are extruded and deposited, whereas selective powder jetting technique use binder for creating multiple layers additively. Okay, so we'll see in a detailed way what is a selective powder binding kind of thing, and what is like FDM. So on the screen, this is a what you can say schematic of selective powder binding thing. Okay, so there is like there is a laser kind of thing. Okay, here, or something heating equipment. These are the material powder, you can say. Okay, and this is the base plate. Okay, or where this structure has to be made. So what happens every time, according to, like, as this is the upper layer, suppose this is the first layer. Okay, so from here to here, this area, it is heated. Okay, through some maybe some laser. So so it is called a selective laser process. Okay, so suppose this is laser. So with the help of this laser light, so it get heated. Okay, and due to heat, the particle fused themselves. Okay, so and once this they fuse themselves, so it again, the heat is like removed and it gets solidified. Okay, so only this portion gets solidified. Once this gets solidified, the hopper is there, it again fills another layer, like this goes down, and through the hopper another layer of material comes over here. Okay, again the required portion is only heated, and due to that heat again the material binded together, and then it gets solidified and a layer is created. So with this repetitive process, this kind of structure you can see can be made, or any other kind of structure can be made. So this is what selective powder binding called. Okay, so here there are two piston, it keeps going down from up to down, and here it keeps going up. Okay, and this hopper every time after every single layer of solidification, it pulls some material from here to, it puts some material from here to here, and this is for the, like, for providing the heat at selective position as per the design. Okay, so this is selective powder binding technique, or you can say if you use laser, so that will be laser, what you can say, this laser technique for doing this 3D printing or additive manufacturing, right? Next is the FDM. So FDM is totally opposite of this. Okay, so in FDM, what we use, if we use a roller, we use a roll of material, okay, in form of wire. So the material is in form of wire, that we call this it as a filament. So generally it is of like polymer or API. Okay, so it feeds to the nozzle. So this nozzle, there's a heater, okay, which heats the this wire and melt it. Okay, and then that melted wire or deposited on a platform, okay, through some nozzle. So as per the requirement of design, this total head keeps moving in XY direction and Z direction, maybe like as per the design of machine, whatever motion it is given, whatever freedom degrees of freedom it is there available in the machine, that 3D printer. So as per that, sometime this table used to move in XY direction, or sometime this nozzle and the heater mechanism, it keeps moving, okay, in XY direction or maybe in Z direction. So it depends on the structure of or design of the machine. So this is the process of like fuse deposition modeling in 3D printing. So I hope you understand, all of you have understand the difference between these two processes in 3D printing or additive manufacturing. Is there any confusion? Hello, I'm audible.
Yes, sir.
Okay, okay. So is there any confusion in this type of like both type of additive manufacturing processes?
No, sir.
So I request you all to just keep interacting with in this session, because this session is just to discuss the problems and interact with you only. Because learning you can do with the courses, with the course content that is placed on the NPTEL platform, obviously. So if you are getting the opportunity, so you can avail that opportunity to get in do more interaction, and so that it can be fruitful for all of us, right? So moving towards the next question that was placed on the forum. So the question is like, the term reproducibility associated with a sensor means. So this is some question from assignment, I think. Okay, so regarding option in quiz 3. Okay, so he's asking about quiz 3 option. There's a question. The term reproducibility associated with a sensor means different output of repeated application of same input value or something like that. So these are the option, and he asked like, what is it mean to be different output? Okay, so here there's a sensor. Okay, we are the question focus on a sensor. So suppose this is a sensor, so it may sense something and then gives some output. So very common example we'll take thermometer, right? So it will show some it has some knob. So here heat will be applied, and then it will give some output in terms of like degree Celsius. Okay, that it will tell us the temperature, right? So here different output means the value of this uh, value of this temperature that it is detecting, right? So the reproducibility here, if we want to define what is reproducibility, so reproducibility means if we apply same amount of heat, okay, at this tip, so it will keep giving us output like this value of this degree Celsius same every time, right? So if we applied same, like suppose if we applying some 1 joule of heat here, okay, here also 1 joule of heat, so if suppose it is giving something like 100 degrees Celsius, so again every time it keeps giving this 100 degrees Celsius, so we will say that yeah, this is a these are the output, these are the input. So here different output means if these outputs are different, so these are the different, we said these are the different outputs and these are the different input. But if it is giving same output on the same amount of input, so we'll say this system, this sensor has a good reproducibility, right? So yeah, there's another example. So suppose if this is a target, okay, so this is a target in some system, and these are the predicted point by some sensor, okay. So if you know that this sensor is producing the result of like this is the output result for the sensors, and every time you are giving input, the result is only in this zone, okay. So we'll say that the system is producing the like is having good reproducibility of the result, while for same input, if the output like it is not out stick to this zone, so output are sometime here, sometime here, sometime here. So suppose these are different values, so we'll say this system is uh, having less reproducibility of the result. I hope you this concept of reproducibility is also get clear with this question.
Yes, sir.
So moving to the next question. So next question is meaning of cyanoacrylate cement Eastman 910 SL. Okay, so it says like I have a question about the happening in this video. What it means like that? Why this material used for strain gauges? Okay, so first of all, what is this cyanoacrylate cement Eastman 910 SL? So this was mentioned by the instructor in the during the lecture class. So he just mentioned the name. So anyone have any idea what this is and or what it is used for? Anyone in the class? This was there in the slide, right? During the lecture when the strain gauge thing was going on, discussion on strain gauge was going on. Yes. So yes, Sudeep. Deep. Sorry. So what is that? This cyanoacrylate cement Eastman 910 SL. Okay. So Nishu, I'm because we are running out of time. I will just tell you. So this is a what I can say adhesive. This is a adhesive liquid. Okay. So we can say super glue kind of thing. So why this is used? So let's go to the previous slide where the strain gauge was there, right? So yeah, so this is a strain gauge, right? So first of all, this strain gauge is there, it has certain elements. So these are the wire, okay. So this wire and there is some silver strip or metallic strip is there, okay. So it is connected with this, then this wire are pasted on something, okay. So this is the base, okay. So that base is known as that base is made up of some epoxy material or something like that, insulator. And for sticking this base on some other part, okay, so where we want to detect the this strain, okay, in the element, the physical element. So for sticking uh, this sensor on that particular physical element, we required some good adhesive, okay, so that the strain in that component directly comes to this, okay, without any inference. So for that kind of thing we required a very good adhesive. So this material that is mentioned here is a very good adhesive. If you google it, you will find some different manufacturer producing this component, okay, uh, this adhesive. So this is a adhesive only for sticking the strain gauge with the physical element, right? So next question that was asked was need of conversion of voltage into resistance. Okay. So question is, we are getting an equivalent value of voltage change due to unbalance of wheat stone bridge because of the strain, which is sensed by the sensor. What is the need of converting the active value into passive value, that is change in resistance? Preferred to the prior discussion, we can accept the value of the voltage alone enough to be understood by mu p or mu c, isn't it? Okay. So he's saying what is the need of converting this resistance to the voltage if there. So I think he has misunderstood the concept of like Wheatstone bridge here. Okay, so what we usually do, we change the resistance value to the voltage value. Okay, uh, for the further utilization with microprocessor or microcontroller, right? So what happens? The system or the sensor initially sense in the terms of change in resistance, right? So suppose if there is electrical wire, if we uh, if the current is flowing inside it, so its resistance its resistance get changed. Okay, so sorry, I'm just giving wrong thing, wrong example for that. So for resistance, we can say, if yeah, so just like in strain gauge, we can see if we increase the this length, so the strain that will impart some strain in the wire, and due to that strain the resistance of the wire will get changed, and that change in the resistance is measured by that Wheatstone bridge. Okay, and the value of that Wheatstone the disbalance or the imbalance of the Wheatstone bridge is sensed in the form of voltage. Okay, and then from that change in voltage, we used to supply that change in voltage as an input to the microcontroller or the microprocessor, and in this way we utilize the sensor to perform the task, right? So there may be some misconception here. Snehasi is in the class. Is Snehasi is in the class? Snehasi, I think he is not in the meeting here. So no issue. Yeah, so these are all the questions that were asked in the question forum. So if now you have any question, you can ask me now. Is there any question to anyone? Or is there any issue? Anything you want to ask, you can ask now. We are open for any query. Not attend the quiz. Okay, so Abhishek is saying, so due to some issues, I was not able to attend the quiz. Is there any chance to give the assignment again? Will I face any issue? Okay, so if the deadline of that assignment is gone, so there is no way to give the assignment again, because after due date, the assignment, the answers of assignments are there. So this NPTEL, according to this NPTEL regulation, you will not be able to give submit those assignment again. However, you can try to give the other assignment or upcoming assignment on time. Uh, the issue that is there only that the marks of those assignment will not be counted into your final score if you opt for the examination. Okay, so this is the only loss. Otherwise, you can see the questions, you can for understanding or for information you can uh, check it, but those score will not be counted in your grade sheet for this course.
Sir, actually, I was just one issue was there that for giving the exam, final exam, is it
Mhm.
necessary that all the tests need to be attended, or I
No,
heard
no, no,
somewhere that
no.
only top eight are considered.
No, no,
Uh,
no, no. Yeah, so this is this consideration of top 8 assignment or considering all 10 assignment. This depends on the instructor. Okay, so how
okay, sir.
he want to grade the course, he has his own rule. Okay, that maybe it get published on the forum only, that portal only. Okay, ki how this grading will be done, or maybe that a rule regulation from NPTEL will be followed. Okay, so there will be no issue like if you're losing any assignment, so it is the loss of yours only. Okay, you will definitely be allowed to give the examination. Okay, but what will happen, like if the suppose this assignment consider of like 10% of the total weightage, so that 10% of that the assignment that you missed, you will be not able to get in the final seat. So this is the only issue that will
Okay,
occur.
sir.
Otherwise, if you are missing any assignment, that it doesn't mean that you are not allowed to give the examination. You will definitely, you have to fill that form and pay the fees, and then you will definitely allowed for the examination.
Thank you, sir.
Hmm. Anyone
सर
else? Yeah.
सर मुझे एक क्वेश्चन पूछना था,
Mm-hmm.
जैसे कि यहाँ की टेक्नोलॉजी में और मैं इम्पोर्टेड मशीनरी की टेक्नोलॉजी में, जैसे मैं एक्चुअली मशीन डेवलपर हूँ यहाँ, और
So Abhishek, sorry for like आवाज तुम्हारी सही नहीं है like.
हेलो
हाँ हाँ
सर, अब आवाज आ रही?
हाँ हाँ.
हाँ सर, इम्पोर्टेड टेक्नोलॉजी जो चाइनीज टेक्नोलॉजी है सर, वो कंपोनेंट के हिसाब से हमें कहीं पे रोबोटिक आर्म में मुझे न्यूमेटिक सेंसर्स मिलते हैं जिसमें रीड फिश वगैरह होते हैं, कहीं प्रॉक्सिमिटी मिलते हैं, ठीक। और हमारा जो क्वेश्चंस आते हैं जो कि रोबोट के बारे में सिर्फ आता है, जैसे आपने अभी क्वेश्चन कुछ किया था, तो देन सर टेक्नोलॉजी और ऑपरेशन के बिहाफ में जो हम सेंसर का सिलेक्शन है वो कैसे करते हैं?
Okay, so selection of sensor on the behalf of technology. Okay, so
ऑपरेशन सर।
so this depends upon like the expertise or the what you can say, the research that you have to do before developing any new technology or developing not technology, developing a new application. Okay, so because the sensors are there, different kind of sensors are available in the market. Okay, you have to choose the correct sensor for correct application. Okay, so for selection of this, you must have a proper understanding of different kind of sensor, and then what is the working principle of those sensors. Okay,
नहीं,
that
जस्ट सॉरी सॉरी सर, मैं interrupt कर रहा हूँ।
yes, yes, yes,
सर
yes, you can.
जस्ट लाइक एक स्क्वायर में और एनपीएम में हमारे एक सेंसर आते हैं, न्यूमेटिक सेंसर, हाँ सॉरी प्रॉक्सिमिटी की बात कर रहा हूँ।
हाँ
प्रॉक्सिमिटी सेंसर आते हैं, एक प्रॉक्सिमिटी सेंसर हमारे M10 M12 और इसमें आते हैं, दोनों का सेम ऑपरेशन है, ठीक। कॉस्टिंग में इतना वेरिएशन आता है कि जस्ट डबल हो जाता है सेम कंपनी, ठीक, लेकिन ऑपरेशन के बिहाफ में सेम है। तो फिर हम इस चीज में हम कैसे सिलेक्ट करें?
Okay, so for that, like for my experience, like I am also building a automated system for my PhD thesis. So what I have to do, like what I have did. So first of all, I have just selected the sensors. Okay, there's like you are saying ki there are two sensors of same company, same working principle, but the cost is different. Okay, so what you have to do?
Cost and size, shape, and everything is different.
Okay, so
Yes.
yeah, so like as per like the thing, what I have understood is ki if you have two sensors, then if the cost is different, so there must be some property difference. Okay, suppose very common example is like in your like everyone has seen that AC, that air condition at their home or some other place. Okay, so when you search for this air condition, so some air condition have copper coil. Okay, some has aluminum coil, right? So the aluminum coil AC, which is having aluminum coil, it is cheaper than that of those copper, although it is delivering same ton of power. Okay, same amount of cooling both are doing, but the element which is inside it is different. So because of those that change in the element, the cost of the that system is increased. Okay, so for you I will just suggest you just check which component or which what are the components that are used in the sensors, both sensor, and which component is more reliable for your application. And not going to the cost, like just think about the cost in long term. Suppose if you are installing a cheaper one, okay, and it is getting it is uh, getting faulty every 2 months or 6 months. Okay, and you have installed a good costly component which is having good quality of material used, and it is not it is working for a year. So that good component is obviously is a worth component for your system. So based on that I will suggest you to select the component, right?
ओके सर, थैंक यू। एंड सर, पीएलसी का कुछ अल्टरनेट है आपके पास एम्बेडेड सिस्टम के लिए?
Okay,
क्योंकि
so
यहाँ पे मोस्टली मैं पीएलसी ही देखता हूँ, और पीएलसी की
yes.
मुझे प्रोग्रामिंग, ये जो इसमें लैडर लॉजिक प्रोग्राम जो इसमें बनता है, और सर ये मुझे बहुत ज्यादा एक्सपेंसिव पड़ा,
Okay,
क्योंकि
so
पीएलसी
yeah,
के साथ।
so
यस सर।
yes. So for PLC, like PLC is a, what you can say is a giant. Okay, so for any application where nothing is working, you just apply PLC and your automation will be on track.
यस सर।
So so
एंड
for like if
लॉन्ग लाइफ।
yeah, and it is obviously a robust and long life thing that people used to prefer. So in PLC also, like there are different kind of company you can search. First of all, like if the what we do as an academician, like we are in institutes and we are in R&D labs. So what we do, we certainly not jump to the PLC. Okay, so for doing any automation or constructing any automated system, we first prefer some microcontrollers. Like if some automation can be performed with the help of some Arduino. Okay, so there are variety of Arduino boards. So if with the help of some Arduino board that automation is performed or not, if it is
सर,
possible, we use
सर,
that.
I already use the Arduino Nano and Raspberry Pi, as
Uh-huh.
you know, so
Mhm.
but they are not for an industrial purpose.
Yes. So yes, what that is what I'm saying. If we start from that stage with the help of like this Arduino Nano, then we move to the Raspberry Pi, then Lete Panda or something like Jetson Nano. Okay, and if the work is not again not fulfilled by all these kind of thing, then we move to the PLC, right? So if our task get completed at this stage, like Arduino with the Arduino Nano or with Raspberry Pi, we'll use that only. If at all it is creating an issue with automation in the system or what we want, so then we jump to the PLC. Now coming to the PLC, there are variety of PLCs available in the market. Okay, you must have
Yes, sir. That's depend
names, yeah.
upon the inputs
Yeah,
and outputs, sir.
yeah, so depends upon the requirement of power, input output, number of pins. Okay, number of component
Resistive
that
type and
yeah,
transistive type.
yes. So number of component that you want to operate with that PLC. Okay, how much powerful those components are. Okay, so depends on that. This PLC, the cost is varying from like from 10,000 also. The PLC is available in 10,000 also, and it is available in lakh rupees also, right?
Yes, sir.
So you have
Yes.
to choose like you have to optimize your requirement. So first of all, you just note down all the requirements, like how like what I have seen, like the number of pins. So if you like there are standard 16 pins are there, then 32 pins are there. So if your work is anyhow, you can cut down your task with 16 pins. Okay, your
Yes, sir.
work is possibly concluded with 16 pins. Then this will be cheaper than that 32 pin if you're going to buy 32 pin PLC, right? And then again there are varieties of companies. So this what I have seen, Delta PLC is there. Okay, I'm not marketing for the any company here, this is a disclaimer. So there is Delta PLC, there is CNC, this Siemens PLC, there is
Mitsubishi.
Mitsubishi PLC. Okay, so you can, if you see, so the Mitsubishi PLC or Siemens PLC,
Patek.
Bentley
Allen
PLC or
Bradley.
Bentley. Okay, so these PLC are costlier than that Delta PLC, right?
Yes, sir.
So you
Cheap and
can
best.
start, yeah, cheap and best. So you can start with Delta. So like for my application, I'm using Delta PLC only. So that is cheaper. Okay, so you
No,
can
sir. But
just
as our director buy the machine from sorry, import the machine from China,
uh-huh.
but they don't use the PLC.
Mhm.
They use their embedded system,
Okay.
their own inbuilt embedded system. So that's because I asked to you, what's
Uh-huh.
the process to replace the PLC to embedded system?
Okay, so for that you have to gain
Because
the knowledge.
embedded, yes, sir, embedded
Uh,
system is expensive and easy to operate,
uh,
because the operator is not much than not much more educated as well we have.
mhm.
uh,
Mhm.
so so we have to build like they operate easily operate, anybody can easily operate.
Yeah, so like in embedded system that you are talking about, inside that if you read about that, those system, there must be some microcontroller and is there. Okay, so those microcontroller are just like these Arduino boards are you that you have used already. Okay, so those microcontrollers are embedded there. Okay, and they, this Chinese firm, what they do, they do not allow you to change anything in their system,
Yes,
right?
sir.
So
in
replacing
fact
those
in fact they don't share their
data
password
sheet.
protected.
Yeah,
Yes, sir.
so that is passport. That passport is this password is different thing, but they even do not share their material data sheet, that the material, this
Te-
component
uh,
is
tech, yes, sir.
used
Technical
in that
data sheet
particular
as
technical data sheet.
yes, sir.
Okay, so this is the
Yes, sir.
problem. So for replacing PLC with any kind of embedded system, you first of all you have to gain some good knowledge about, sound knowledge about the working of the system. Okay, and what you
Yes.
required actually, what is the your requirement about, like for what you are going to develop this automated system. So first of all, that need to be clear. Okay, that concept need to be clear. Ki, okay, you want the automation system for this purpose only, and once you have clear idea of that, then you can employ it from starting from a small microcontroller to like keep add on. Okay, and once you get like your work is done at certain stage by using certain microcontroller or some other controller, so you can stop there and you can use that in spite of PLC. So this is an approach that you can follow for replacing those kind of system like the PLC in your automation. However, this PLC, like I don't think so. This PLC is creating much more problem in industries. Like all industries, like I'm working with an industry, they wanted PLC in the system so that this automation can be easier, because this PLC is so powerful that it can control machine. Like if there is machine cutting machine, inspection machine, and then what you can say,
सर जिस
filling
कंपनी
machine.
में सर जिस कंपनी में आप गए थे विजिट के लिए, टेक्सटाइल की KPPL कांकर प्लाक पॉली प्लास्टिक
हाँ
प्राइवेट लिमिटेड,
हाँ.
सर उस कंपनी में जो वाइंडर है, एक्चुअल में सेम वाइंडर मेरे पास
ओके
है
ओके
यहाँ।
ओके ओके ओके.
और सर उसमें भी मैंने देखा कि टोटली सारी चीजें फुल्ली ऑटोमेटेड है, वो हमसे आज भी 10 साल एडवांस है।
Definitely. That industry is very,
यस
what you
सर।
can say, very advanced, and their
लेकिन
industrial soft floor is very automated manner, and
यस
and
सर।
they every day they used to do research. Like for R&D activity, I went there, so they had lots of project and they wanted to implement automation every place. At every place, uh, they want to minimize the human intervention, right? So for that purpose, they are installing different kind of automation devices there. Okay.
ओके सर, थैंक
Hmm.
यू फॉर एवरीथिंग सर।
Thank you, Abhishek. Thank you for interaction with us. And okay, so we are running out of time. If anyone have some question, you can just have a quick question we can take, and otherwise we'll close the session. Is there any other question? Okay, so thank you very much, everyone. We'll meet next Saturday, same time, same place. Till then, take care and keep learning. Thank you.
Thank you so much.